Today's class is on deep foundation continuation, mainly on. Can you all see the slide and the laser pointer on the slide, moving on the slide?
Yes.
Okay, thank you. If at any time you cannot see the slide, please tell me. Don't keep quiet. Huh? No point. I'll be talking to somebody else then. Right. Again, this is following the same CLO2 outline building elements such as foundation. We are doing foundations, then goes to floors, walls, roofs, and building finishes. There are a few more elements. We will cover it in coming weeks. But foundation is the most important part of the building. One have to design, construct, monitor properly all through its service time, isn't it? Right. So let's see what we have done last class. Last class we started with shallow foundation, the types. No, we continued with shallow foundation types, right? May I ask one question? Just review question. Area of footing is given by anybody? Area of footing is given by, this is done already for you.
Total load divided by the safe bearing capacity.
What do you mean by total load? Any other? No, you don't answer. Good, your answer is correct. What do you mean by total load here? Can anyone tell me? You also studied design different types of loading coming over the foundation, isn't it? Answer me, please. What are the types of loading? Quickly.
Soil and retaining wall.
Uh,
Soil and retaining wall.
Weight of the soil. What do you mean?
Yep.
No. Are you using constructing a soil building? I mean embankment, an embankment? No. I'm talking about the loads that is coming over the foundation. We are not doing any embankment construction. Then you can say soil load. This is for mainly for construction of buildings, superstructures, skyrise buildings, right? For this, what type of most common type of loads that will be considered for designing foundation? I have given, right? We studied design different types of loading coming over the building.
Dead load.
Dead load.
Means self-weight of
Static
the
load.
building
Live load.
plus living load or live load, right? And then or living load, live load, or moving load, including wind load. These are the main three types. You can also include earthquake loading, right? Dynamic of the building due to soil strength also can be included as a fourth type of loading for complex type of building construction, right? Or if there is any poor soil, the construction is under the poor soil, or the building is sitting on a flood prone areas, it is mandatory you need to construct. Then you have to go for all types of checking loading, right? So the definition is simple definition: total load including self weight, right, includes all types of loading coming over the building over allowable soil pressure or bearing capacity of the soil. Bearing capacity of soil, you can take a sample and test it to know how much is the tonnage or kilonewton it can bear per meter square, or just the kilonewton, right? It depends on how much, with what you are comparing, right? Types of deep foundation. Today, I mean, we also started with types of deep foundation last class. Types, mainly they are classified into piles, piers, and caissons, right? Deep foundation is recommended when dash and dash. Based on what you learned last class.
Heavy superstructure.
Very good. Heavy load. I hear only one voice. I'm sorry, you have to answer. All have to participate. When I ask, you can even say chorus. Then it's, oh, good active participation from school. Tell me. Deep foundation is recommended when heavy loading, one answer, right? Concentrated loading is coming. Then you go for deep foundation, and then mainly there may be a few others, like 4 or 5 cases or conditions under which you go for deep foundation. But mainly, whenever there's a concentrated superimposed load coming in, heavy load coming in, you should go for deep foundation. Second,
Poor soil bearing capacity.
poor soil, right? Or poor bearing capacity. Soft soil is so deeper, then you go for deep foundation until you reach a strata beneath the ground or very deep into the ground. Lastly, we did quiz. I'm sorry, I didn't pick the result yet. I will show you later, maybe end of the class. And then objectives of today's class will be mainly on classification of files based on site condition, the types of files based on site condition, types of files based on the material, and the installation of deep. Any question? Any question? Please mute your microphone. Guys, mute your microphone.
Kalau udah makan,
Installation
ini
of
makan lagi.
How many of you join? Very good, 92. Please answer me. Can you see the slide? All of you can see the slide?
Yes.
Okay. Mute your microphone, please. We are here, right, talking about the deep foundations. Some of these definitions are all done already. We are at this stage, right? Types based on material and magnitude, right? How deep it can go based on a range of depth is given for different types of files. In this, the maximum distance that it can go inside the. Hello. What's going on? What is this? What do you want? Okay, let us listen to your music first. Nice song. Who is this?
Teacher, are the slides have been uploaded?
Yes, already uploaded in both MS team and I think in I don't remember, but I mean last week itself I have done both, but MS team confirm. But I need to check in CN because it was done last week. Okay. Slides are there in MS team under file section, under files and the class material. Right. Maximum height it can go inside. For concrete pile be 150 at the maximum 160 if you want. Then you choose steel pile or shaft pile. These are the classification under the ground, right? How deep they can go inside. We will see one by one. I don't want to repeat it later on, but understand the materials, timber, and then all these types of piles which is used, and the different types of soil layer one can see below the ground. It is not of one layer. It may be some organic, some outwash, some clay, some outwash again, and then glacial, and some and reaches the bedrock. Bedrock is the hard strata or the impervious layer which can hold the footing or a foundation firmly into the ground. And we stopped until this, I suppose. Right? Let's see one by one now. This is again based on the types, right? The types in the construction. Piles. You see here the piles is constructed. The piles are constructed to hold the transmission tower here. This is acting as a foundation for the transmission tower. What are piles? Piles are generally driven into the ground in situ, or other deep foundations are typically put in place using excavation and drilling. So piles mainly may be driven or by excavation. We will see how it is and by drilling. The naming conventions may be varying between engineering discipline and firms. Okay, piles mostly driven or poured or constructed by drilling the casings and so on, right? I will explain it the diagrams and videos later on. Just hold on. Deep foundations can be made out of timber, steel, reinforced concrete, pre-stressed concrete, right? These are the materials. Don't forget, don't use any other material like plastic, polyester, polyethylene, right? And you can try, but that would be a new finding from your side. Strong material which can hold piles or which can act as a piles under the ground. So currently we have timber, steel, reinforced concrete, pre-stressed concrete. We will see one by one, and according to situation, site condition, type of soil, right, and type of loading, type of climate also changing. Piles, relatively long and slender members, relatively strong, long, slender members, maybe about the cross section. If you see just 10 centimeter, 10 centimeter, 20 by 20, it depends on the design. Each pile may go for 10 centimeter, 20 centimeters in square or rectangular or circular, right? transmit the foundation loads through the soil strata of low bearing capacity to deeper soil rock strata having a high bearing capacity. So the purpose is to transmit the load or transfer the load to the hard strata. Okay, what's going on? Some disturbance. You have any question? Am I going very fast? Am I going fast?
No.
Okay. Whenever I go
Yes.
fast, the statement is not clear, please stop me. All right. How many joined? 99. 114. I have checked all the numbers in the group because we are going to have soon we are going to have presentation. Evaluation is there. Don't enter any other anonymous name. You have to give your true name, and if anybody wants to join other than these members, they can give the request. I remove all the others so that it is clean list for us. Okay. Okay, let's move
The
on.
presentation is on 12 week, right, teacher?
Yes, yes. Can you see the slide?
Yes.
Okay, good.
Yes.
It's all repeating statement. Let's not do it and then go here. Pile foundation is used when it's important. When you can use the pile foundation does not have sufficient bearing capacity, estimated settlement of the soil exceeds the tolerable limits, right? There is a settlement due to soft soil nature, differential settlement due to variability and non-uniform structural load, right? Again, both you can see above ground and below ground. Above ground and below ground is worse situation, then you go for deep foundation. Like very heavy load is coming superstructure, and then underground you have soft soil, so settlement is more, differential settlement is more uniform, and I mean there is no proper distribution of loading inside, and the soil strata is full more of saturated than unsaturated hard strata. All these conditions you should go for pile foundation to reach the hard strata underneath or beneath the ground at deeper locations, right? Excavations to construct a shallow foundation on firm. Wherever shallow foundation is not suitable, you can go for deep foundation. If you start constructing shallow foundation in loose soil or less bearing capacity soil, you will be losing your fund. It will be an expensive project. Whenever it is necessary, construct a building along a seashore or riverbed. So all these seashore and riverbed, what type of soil it is? Come on, quickly. You answer, you have to interact more. By then you are learning. Seashore, riverbed, what type of soil it is?
Non-cohesive.
Sand.
Non-cohesive, they cannot form
Cohesiveness.
yeah, cohesionless, non-cohesive. They are not firm, they are not brought together, they are not, they cannot transfer the load down to the earth. Whenever there is a water condition, right, we mix with the water also, there is a expansion, possible expansion. All types of settlements are possible. So you have to go for pile foundation. When the structure carries heavy concentrated load also, you should go for pile foundation. Come on, let's understand about pile installation. Okay, installation by driving, another one is by boring. There are two different type. Please don't get confused yourself. There are two different type. By driving, when I say driving, you already have a pile in hand, right? So mostly it is advisable for precast prefabricated concretes or piles. Installation by boring, you have to bore, you have to make a hole and then see what is going on, how it is being constructed, right? So they are two different and both are successfully used in many different places. We will see why and where they are appropriately used. Okay. Deep foundations purpose, transfer building loads deep into the earth again. And you see some examples of piles here. Drilled or bored port, bored or port, right? Means what? A bore means what? Hole. A hole or a gap is created first, and then concrete is poured or any slurry material is poured to make a concrete, to prepare a pile. In this also same type. It is drilled, a hole is drilled, bore means what? Hole. A hole is driven into the ground, and by having proper casing or a well type of structure with proper pile cap, you can construct proper pile arrangement like this. They are called caissons or bored piles. driven piles. These are all already built somewhere in the manufacturing site and brought to the construction site by means of machineries like cranes and heavy equipments. All are operated by hydraulics, mostly operated by hydraulic press or hydraulic mechanics, driven into the underground, right? Driven into the ground to hold the soil firmly. They may be end-bearing or friction type. We will see one by one. There are a lot more stories and slides available. Let me explain one by one. All these things are reaching the ground. This one may be at some place or reaching a medium soil. I will explain why it is like this. Driven piles. Okay. Driven piles. Just now I said driven piles means you have the pile in hand already fabricated. Let's read. Can anyone read this slide? Installation of piles. There are some terminologies. It's good one of you read this. Please help me. I start from beginning so that everyone will have the chance to talk in the class. Abdullah Tahir Koraya. Come on, start. Can you read the slide? 102.
Yes, ma'am.
Please read the slide. Pile installation. First point. Driven precast piles.
Yeah, driven precast pile. The pile is casted in a wad brought to the site and driven by some mechanism into the soil.
So
yeah.
By some mechanism we will see later. Thank you. We will see what mechanism used to drive the pile into the ground. You already constructed, but you are going to just drive into the ground so that your pile construction is, your deep foundation is completed. Next, driven cast in situ pile. Next man, please take the name. You cannot jump. Later I will use the attendance sheet. I take it sportive because you are hearing one voice and boring. Adel Gamal. Adel Said Silaman. Adel Gamal. You're there or not? Adel Gamal, don't waste. We are having interesting things to do today. Video, quiz. Adel Nabil, Ahmed Nabil. Ahmed Nabil.
Yes, miss.
Please.
Driven cast in situ pile. Casing plugged at bottom is driven into the ground, and then the pile is casted by removing or retaining the casing.
See here. So this is another type, and it's very interesting. Driven cast in situ. In situ means at the side. Okay. In situ constructed at the side. How? A casing. A casing means a hollow type. A pipe or hollow type. Casing like a scaffolding or like a formwork. A casing plugged at bottom is driven into the ground, and then the pile is casted by removing or retaining the casing. Okay, so this one I will show by picture so that you will clearly understand. For now, understand that instead of inserting a pile which is precast already, they will put the casing inside and then the concreting is done. Board precast pile. Okay, here board precast pile. Next one, a board is made. Here a hollow pile is inserted inside so that a pipe-like structure is formed inside the ground. Here a board is made or a hole is made, the soil inside, and the soil inside is removed, and then because it might be loose soil, you cannot use it. In this case the soil might be good, so they just make a casing, prepare like a pipe-like structure by using this casing. Either the casing is placed over there or removed because the loading is not taken by the casing here. Now in this point, if the soil is not sufficient, the bearing capacity is not good enough, it's a soft soil, then you have to make a board, remove the soft soil, and then pour soil inside there, and inside is removed, and then a pile casted in some yard is put into the bore. Okay, casing is holding a pile, prefabricated pile inside. It may be called as board precast pile. A precast pile, but still it needs the a casing inside. The casing is driven first and a pile is inserted into the hole, right? Again here the scaffolding and the formwork will not take the load, only the pile will take the load. That scaffolding might be because of erosion. It may be erosion surrounding the soil. Say for example a bridge construction, pile foundation which is constructed for holding a bridge, or in the construction of a bridge which is always available at the water, inside water, chances of floating, chances of sliding, erosion is very heavy. Board cast in situ pile. A board is made, the soil is removed and the pile is cast at the site in the bore. So a hole is created and the casing is removed, a concrete is poured, okay? By means of construction of the concrete inside, the casing is removed. We'll see one by one how it is. If I talk, you will not understand. We will see this. Before I go into all these things, let's see the video. Okay, where is the video? One moment. I see. One moment. Can you all watch this video so that you will understand how the pile is cast, installed into the ground. Let me share the slide for you. It's already shared, right? Yeah, it's already shared. One moment. Let me take the audio. How a pile is installed in the ground. I'm going to show this. Can you all see the video? Can you all see the video?
Yes.
Okay. Can you hear the?
Yes, yes.
Hello, piling friends. Today we'll be talking about pile driving method. Pile driving technology is a process where already built piles are driven into the ground with the help of a piling rig and an impact hammer. Piles can be concrete precast piles, steel piles, or wooden piles, depending on the required application, grounds, feasibility, and so on. The pile driving rig is a hydraulic heavy machinery that's composed from the...
Please listen carefully. I will ask question at the end of the class from the video. Please listen carefully.
Base machine, self-erecting mast or leader, and a hammer. The machine sizes can vary.
Check the audio. Okay, good. Sorry.
Hello, piling friends. Today we'll be talking about pile driving method. Pile driving technology is a process where already built piles are driven into the ground with the help of a piling rig and an impact hammer. Piles can be concrete precast piles, steel piles, or wooden piles, depending on the required application, grounds, feasibility, and so on. The pile driving rig is a hydraulic heavy machinery that's composed from the base machine, self-erecting mast or leader, and a hammer. The machine sizes can vary from approximately 40 tons to approximately 100 tons, depending on the required leader capacity, length of the pile, and the impact hammer's weight, but also depending on the angle of the pile, as piles can be racked as well. The impact hammers used on the rig are the main assembly performing all the work and should be carefully considered, depending on the work required. Impact hammers can vary from 6 tons weight to approximately 40 tons weight, obviously depending on the diameter, length, and ground conditions. For example, a Yuntan PM25 pile driving rig with a Yuntan HHK5 7S impact hammer has the ability to drive 30-meter piles of approximately 850 millimeter diameter in the ground, thanks to its 103 kNm energy from a maximum drop height of 1.5 meters with anywhere between 30 and 100 blows per minute. Although it looks like a very simple process, the pile driving method requires very skilled operators and assistants due to numerous variations that need to be considered. A few examples of the factors that need to be considered by the operator when driving a concrete pile into the ground: the number of blows per minute, the drop height, the energy applied, the angle of the pile, the composition of the soil, layer by layer. An extremely important step in the process that requires all attention is the pile handling, due to the weight and the length of the pile. A pile can vary between 200 kilograms and 5 tons. Pile driving technology is used around the world for bridges, land and marine work, as well as for residential and commercial building. Geography-wise, pile driving method is used almost all over the world due to a large number of applications. Next week,
With this, the video stops. Okay. Are you there? Hello, can you hear me?
Yes.
Yes.
Okay. Can you tell me what is the rate at which it is driven? There was a rate he was explaining at which it is driven. Rate, how many blows required to plug in, how much distance inside the ground. There were a different 30 blows for
Per minute.
for 2 meter, 1 meter, 2 meter, you can imagine, right? Just for 2 meter to be driven with 30 blows, the hammer with the 30 blows, for example, you can imagine with 30 blows, it can drive 2 meters below the ground. Okay, that's an average or an example rate of pile driven into the ground. And using different types of hammers, different types of fuels operating the hammers can vary number of the performance, okay, based on the number of blows, number of the time taken and the distance driven. Okay, where we are somewhere before, right? These are all important when we are here. Advantages and disadvantages, why it is necessary and not necessary at locations where shallow foundations can do better. Can be driven in a very long lengths, can be designed with to withstand high bending and tensile stresses, right? Why tensile stresses? It is, can you tell me? Because it is like any building, if you see, if you take the foundation as a support and the structure as a beam, it is acting like a cantilever beam, right? So chances of tension is more, right? Or deflection is more. So to take in account at the very beginning, the high tensile stress, these types of pile foundation will be helpful. And then if it is shallow, very good chances are immediate chances of failure of the building if you adopt a wrong foundation like shallow foundation for a skyscraper. Construction operation not affected by groundwater, because you are going deep into the rock surface for a pile foundation. It will not be affected by a groundwater. You don't bother. It may be crossing by, but you will still driving the pipe into the rock surface. You're not reaching the water surface. You will be passing by and then reaches the rock surface. So you're safe from groundwater interruptions or any moisture changes in the foundation resulting in any settlement or differential settlement of the building, right? May break, disadvantages, may break during driving. Yeah, care should be taken. This is what he was explaining in the video also, right? Proper angle, proper hammering, right? You cannot speed up, you cannot very slowly driving into the ground. Proper speed and maintaining proper angle, you have to drive the pile in place. May suffer from unseen damage which reduce carrying capacity. Yeah, chances of unseen damage like by the sides or by overusing the hammer or by sudden changes, sudden accidents, right? And then noise and vibration during driving may cause issues, right? You have to provide proper noise reduction. You might have heard always the kind of a hammer sound, tuck 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 like that, right? Hammering sound. These are all sound for pile foundation. They are hammering the pile into the ground. So you have to avoid by proper insulation materials to reduce the noise produced from the site. Displacement of soil. See, it is even vulnerable. One time when the student, when I was working in Nottingham, one student, there was a construction going on. The student immediately started a project on how the noise will affect facilities like students are studying, the classes are going on, operation is ongoing, right? Functionality of the building is ongoing. At the same time, there is a building construction design within the campus. So he took the project found out how this noise will reduce and how effectively they will do the construction, and also the operation daily routine operation will keep going on, right? So it's like to that extent it is very noisy. It has to be researched, it has to be analyzed to reduce the noise so that it is not affecting the dwellers in the same place or neighbors. So it was a wonderful project he was doing, and the results were, and the strategies that he has come out with was very interesting. Mainly he touched upon doing the construction at the night, overnight, and then free of the day, during daytime, and then using quick setting cement, something like that, reduce the erosion, at the same time reaching the strength of soil and the grade and so on. There are different solutions he brought down. I don't remember everything, but to that extent it is important you have to give proper attention to the noise pollution and its control. And displacement of soil during driving may lift adjustment piles or damage adjacent structures. Yeah. You must check the soil condition. You must check the soil condition, especially when you are driving the bores, driving the casings into the ground. There will be a time taken between completion of the casing and then pouring concrete, right? So in between you have to handle properly so that there is no sliding of soil into the pile, because unwanted material is going into the pile, right, and into the casing, and there is chances of movement of the casing, especially when you all these struggles and challenges will arise when you are constructing with the loose soil, and then seashore construction, and then construction of bridges across the river, right? There are chances of floating of the casings, at the same time erosion, right? Erosion of the abutment and the foundation. There are chances of removal of the pile cap itself. So you have to properly dewater, have the proper scaffolding before you start pouring the concrete, and the time is also to be managed properly. Okay. Driven pile installation. All pipe driving equipment, including the pile driving hammer, cushion, helmet, pile cushion, and other appurtenances to be furnished by the contractor shall be approved in advance by the engineer before any driving can take place. So all the PPE and the preparation for the pile driving should be taken care of so that you can avoid any accidents or unwanted situation. To obtain this approval, the contractor shall submit a description of the pile driving equipment to the engineer before pile driving begins. The description must contain sufficient detail so that the proposed driving system can be evaluated by the engineer. So proper arrangement from maintaining proper angle, proper distance, proper rate. You should validate the equipment, whether the proper rate of performance is there or not, and the fuel is filled, right? And the drivers are in good condition, attitudes of the driver, everything is important, because all people at construction site they are working at the cost of their life, right? So you must check by all means and get proper approval before the work is started, because huge hazard, right? High hazard and risks are involved. Chances of accidents, chances of high chances of threats are invited. To avoid all these things, you must have proper preparation before you go for piling. Hammer types, right? You saw a hammer, right, in the video. The hammer is blowing, right? Blowing the pile into the ground. These hammer types are different. They are different. Here you can see drop hammer, single acting power. This may come in your Kahoot, your quiz. Please remember these points. Double acting power driven hammer, diesel power driven hammers, vibrating and sonic power driven hammers. Although it is mechanical equipment, but you should know at least which is the best one, if not all the types, okay, so that you can suggest, right? Drop hammers, gravity hammers, how much it is? Efficiency very low, very low. It's not only about this efficiency, it is related to the type of soil. When you buy the hammer, they will give you the descriptions, okay? The manufacturers will provide you the conditions at which it will work and the efficiency, type of soil, and the performance details, okay? Okay. And then here, hammer efficiency shall be adjusted for better driving. Okay. Single acting power driven hammer, which can go for 67. Okay. Above all, the best performing one will be hydraulic or diesel with built-in energy measurement. Okay, diesel operated with built-in energy measurement. This is only diesel, and this is with hydraulic. Okay, in one word you can say hydraulic operated. Hydraulic powered machines are reliable and long lasting, giving good performance compared to air system, whatever it is, double engine, double steam, single steam engines. Okay, hydraulic systems are giving good performance overall, right? With the diesel, with the diesel as a supplementary energy. Okay. What else? Vibratory and sonic power driven hammers. It's not given here, but it's one of the classification among the hammers. But the best performing one out of all of them is hydraulic or diesel with built-in energy measurement. Okay. If you want, I can show the different types of hammers here. But if you type in the Google, you will get the pictures, right? That's not a scope of the study. But understand which is the best performing. Okay. Overall, most of the machineries in the site are powered by hydraulic principles, and then diesel. Okay, using diesel for heavy duty engine, operating heavy duty engines at the site. So they are successful and performing well. Drop hammer, gravity hammer. How is it? It's looking like this. Okay, and the arrangement is like this. The hammer location is like this with the, okay, the capacity of the hammer is also important, right? Capacity of the hammer determines how many blows and how long you're going to do the operation. For example, it is 650 kg. How many newtons? How many newtons or kilonewtons? Quickly. 650 kg. It's better you say by kilonewtons, because we all measure by kilonewtons. The weight, the pile capacity, everything is measured by kilonewtons, right? 650 kg, so how many kilonewtons? Anybody? No idea.
6.4.
How many newtons? First of all,
6,376.
yeah, 6,000. Just let it be 10, round to 10. So 6,500 newtons, right? Divide by 1,000, it will be 6.5. 6.5 kilonewton you're using to hammer it, to drive this one, this kg. Pile capacity, this kg is 140. Again, this will be 1.4, right? 1.4 kg pile. This may be a short pile, or for a strong soil. Maybe that soil is very good. That's why they go for shorter distance. And the load coming is also bearable. Okay. It consists of a steel ram that is guided with a set of leads. The hammer is raised to a certain height and allowed to drop, raised to certain height. This is the leverage, the column in which it can move in. So it can be raised to a certain height and allowed to drop on top of the pile. Okay, thus producing a driving action. Okay, by impact. This is producing an impact on the. What principle is it? Anybody can tell me? Although it is slow, we should not forget these people. Fluid mechanics. What principle is applied here in driving the pile? Quickly. Fluid mechanics. 3 types of principles you studied in fluid mechanics, right? Answer me. Can be wrong, please. How many join? 104, 10 missing. 10 I didn't remove in MS Team yet. I'm giving grievance, still giving grievance. Please let me remove from MS Team also by today. I'm supposed to do it. Please settle the payments. So you should be 114 inside. Okay, answer me. What did I ask? Well, let me download this first. Here we are. I asked a question, right? What question I asked? Principle. Quickly, so that you recall your fluid mechanics. Can you state any principle under which it is moving inside? What is happening here? Why nobody is answering? You're 104. What? Now I'm asking what type of principle is used to drive this? What type of action is taking place here? You studied 3 principles in fluid mechanics, right? One of them is used here to drive the pile inside. You shoot the gun. You have studied examples of shooting gun. By what?
Conservation of momentum.
Fantastic. Very good answer. Momentum principles and force momentum principles, right? So the force, the net force acting on it will be the equal to change in momentum, right? M into V, right? Okay. So the impact is created onto the pile. Thus the pile is moving inside. Okay. It is the net force acting on the or distributed over this pile and will be causing the moment of the pile inside. A simple word, impact, right? An impact is created over the pile. Thus it is driven into the ground. Good. Vibratory and sonic power driven hammers. Okay. Last time it was a hammer just gravity driven, right? As long as the load is increasing, it will be the weight is increasing onto the pile, it will move inside, and also by momentum. Then here is a vibratory. By vibration and sonic power, the pile is driven into the ground. Let me read this. These are the most recent developments in pile hammer technology. They are comparatively heavy, requiring handling equipment of greater capacity than required for conventional pile hammers. Okay, the vibratory hammer vibrates with the pile at frequencies and amplitude which tend to break the bond between the pile surface and the adjacent soil, thus delivering more of the developed energy to the tip of pile. Yeah. Some electronics means they are produced by electronics means by producing sonic waves, right? Sonic and vibrations at the tip of the pipe. The total energy is converted. The vibration is converted into kinetic energy or moving energy, right? The total vibration is electronically converted into kinetic energy. Kinetic means movement energy at the end of the pipe so that the pile can move inside the ground. And not much technical draw or design is required, but understand the mechanisms by which it is being driven. Pile installation. So mainly all these types of piles, whatever the maybe classification made by materials or site condition or by action or by loading, in all they are classified into mainly into 2 different types, which is installation by driving. So far we saw installation by driving, and there are some more slides, interesting slides to know more, and then installation by boring. We've done this. Any question on drilling piles? Driving piles or drilling piles? So far we saw driving piles. We'll come back to the driving piles later. Some advantages, disadvantages, some pictures related to that. Any questions so far?
Miss. So how if the pile is cracked during the driving?
You should avoid cracking, number 1, right? And that means you would have chosen the type of pouring file rather than precast file. In places where there is chances of cracking, you should go for board files rather than prefabricated files. You should avoid cracking of concrete. You mean that during construction, right? What if there is a crack?
Yeah.
During construction, you need to replace. Of course, you need to replace. You need to identify first of all, right? For that, you should avoid cracking in first place by properly choosing the material. That's important. Later, you will also see what are the materials which is tend to prone to cracking, which is not, and which is faster in grasping the moisture content, and then which is strong enough in such certain situations. So you should avoid such breaking materials or cracking materials, number 1. And during construction, care should be taken. The cranes, the operation of the cranes and the drilling rate should be properly chosen such a way that it is not cracked. If cracked, have to replace. It consumes money, effort, and time, isn't it?
Yeah, okay, thank you.
That's why the approval is necessary. If you get proper approval, the engineers, geotechnical engineer, mostly done by geotechnical engineers, professional engineers will check based on the type of soil, whether it suits the type of soil with the type of structure and the type of pile chosen. Okay, but it's a complex mechanism. That's why you see the preparatory things. Just now I show you, they get approval, they get a proper equipments, right? All these equipment should be properly chosen and got approval. There is a separate approval. The contractor should get approval before the pile driving is started. So you can avoid any type of failure. It may be cracking, swelling, and then thrown off, right? Sometimes during handling itself, handling from the source to the point where it is constructed itself, there is a chance of failures of breaking. You should also avoid more storage stocking piles. Next type is a board pile. Board pile is another type of reinforced concrete which is used to support high building which has heavy vertical load. Right? Board piles. Board pile is a cast in place concrete pile where it has to be cast on construction site or in situ. Mostly board pile is not fabricated one, not a precast one. It has to be constructed at the site by boring. Let's see one by one. Advantages. A length can be easily adjusted, right? Last time prefabricated, you cannot adjust it and you cannot choose the material. Unfortunately, if the contractor supplied all concrete, you have to live with the concrete, and all wood, right? You have to choose appropriate section. Sometimes you cannot be choosing each and every stage of the work, right? Or every stage, like you finish all the main structure and you go for the structure surrounding the building, and you may want to change the type of material. You don't have any new, I mean, you already have a stock of all wooden precast that is already chosen. You have to go for it. You have to use the stock material only. Unless otherwise it can be chosen, you can go for the required and the appropriate one based on the conditions of the site and the construction. Here material in pile not governed by handling or driving stresses. So you can avoid handling issues because you're going to construct. Noise and vibration can be reduced, will not disturb adjacent structures, right? You're going to pour hardly, it's a vibration of the machine which is mixing concrete or the material which is being poured. It may be chemical. Sometimes if short piles, they use chemicals to form the ground. Okay, so if chemicals and short foundations is even more easier, no noise, you can have a proper control. So these are the advantage of casting in situ, right? Mainly on the length can be adjusted, chosen, because you may design one length. At going to the site, there may be some boulders, some hill types, some rock already under the ground. On top you're going to construct, so the length going to automatically changing. So it is easy for choosing that particular length which is available at that point, right? Rather than the designed one which is supplied by the contractor. If you're going to break it and resize it, customize it to the depth required, it will be losing the strength, or there may be chances of losing its property, right? And then one more thing, all of you have to understand this point. I think you know, I'm just recalling you. So the soil and the type of soil, the type of structure below the ground is invariably varying. Every meter, not even a meter, I can say 1 foot, let it be 1 foot. Even every foot in the diagonal and in the downward is changing, right? It is not unique. Every foot it is having different type of structure beneath the ground and also on the ground. So the sampling points that you have chosen on the ground will not be uniform for a building, right? It may be changing, it may be varying. In that case, if you are using prefabricated concrete piles or wood piles, you'll be wasting your money. But this type of cast in situ will have adjusted, or you can decide the depth of foundation according to the points that you want to construct. Concrete can't be inspected. It is advantages. Concrete can't be inspected after installation. Yeah. Precast all tested, right? After fabrication, they tested for strength, how much strength it is going to hold, and what is the durability. By all means, they are tested, right? Tensile strength, compressive strength, sorry. All type of strength is checked before you have the value in hand. And then concrete can't be inspected after installation. You can only confirm by the grade, what type of grade you use, and the corresponding concrete strength can only be achieved, right? And this is not a major problem, but at times if you want to change the strength, you will have to choose for cast in, fabricated. Displacement may damage the fresh concrete in adjacent pile or damage adjacent structure. Yeah, care should be taken. That's what I said. When you constructed the casing, care should be taken, properly position the casing first, and then pour the concrete so that it is not mixing with the other materials. And then it should be unique, right? Can't be driven with large diameter, right? There is a chance of it takes longer, right? The piles are very deep, right? Deep into the ground. So you have to make sure that proper settlement, proper compaction, proper pouring, and proper thickness of the concrete should be achieved at each and every layer of the concrete, right? It will be complex and tedious job when you go for 4 board piles rather than a fabricated one, especially for large diameters. Can't be used in river or marine structure without special adaptation. Yeah, because it will be always floating. The casing will be always floating if you choose bore piles in. But bore piles are the appropriate one in case of what is that? In marine structures, in water structures, because it will not affect. It will take time to affect the main structure, right? So that's why they go for bore piles. But it will be tedious and difficult to construct in marine structure or water retaining structures. Okay. It's going like this. Wait. Can you see the slide? So far you are seeing the slide or not?
Cannot.
No, miss.
Why you didn't tell?
Just can't see.
Just go. I didn't show any picture, unfortunately, but if the sentence are important, you can get along with me. Wait, I will share the slide. Okay, there is a picture now. Let me share the slide. How many of you? 107 only. 7 more people missing. Please remind me, one of you. I cannot keep asking you. I will try. I will try to use the PowerPoint itself as a presentation media. I have a plan. I already learned how to do that. I will do that so that this kind of sharing is not a trouble for us. Okay, but remind me then and there. Otherwise, it will be boring. But some words you can read from clearly from the slides. Where is it? Can you see the slide now?
Yes.
Okay.
Yes.
Right. Board pile installation. Am I here? Yeah. We just finished the damages and all these things, and advantages, disadvantages. Some of them common sense and some of them technical. So you should try to gather all the information. Here some understanding and remembrance required. Okay, I have a basic question. These are the foundation types and classification, installation you are learning. I think you have one module on foundation engineering design, isn't it? Foundation design you are learning, isn't it? How to design a foundation. Answer me.
No.
No. Why it's no? Do you know the program structure? Seniors, can you answer me? In program structure, there is an exclusive module on foundation design. That's most important. This will be the basic module for that design. Seniors, can you answer me? Did you take any module on foundation engineering? It is not foundation in engineering, which is pre-degree program. No, I'm not talking about that. Foundation engineering. It will deal about how to design a deep foundation, how to design a shallow foundation. Design means what? You calculate all the types of load, properly suit the dimensions of the footing. If it is shallow, if it is pile, what is the depth, what is the diameter, what is the if it is the reinforced one, what are the reinforcement arrangement, if it is a concrete one, which grade, which depth, right? Answer me. Seniors, please answer me. Otherwise I will call by name. Don't help me to say whether foundation design is taught to you or not. Otherwise I'll go for one design. I can take design of one pile. It'll take 2 pages only. I have to use the whiteboard to design it one by one. 2 pages design only for a typical member. Excuse me, hi. I'm sure you are learning beam design, column design, right? And slab design, and the analysis also you are learning. But coming to foundation, there is a subject on geotechnical engineering line, like soil mechanics, geotechnical. Maybe in geotechnical or exclusively on foundation design you should be doing. Are you doing it or not? Answer me. Important for you. Otherwise I will come out with one design. One class I will teach you how to do the foundation design.
I think yes.
You are learning, right? Separate module.
No.
Yeah. In RC2 also,
No.
in geotechnical also.
You have one chapter on foundation design, right? Because if it is taught, I don't want to repeat. If you are going to learn also, I don't want to do it, okay? Otherwise, you should know how to design a foundation, okay? Okay, let me check. I got the module, but I don't have the paper right now with me. That's why I couldn't check. Later, I check with other lecturers, Dr. Ilya, Ramesh, I will check. And then I come out with a design if you want, okay? It will be for half an hour. I will try to complete in half an hour one design, taking a building and how to design a foundation. It's interesting. Engineers outside, they will be doing it in a small paper. Quickly, they calculate and they will tell, right? So you should get well versed like that, expert engineers. See, in US, before COVID-19, construction engineers are the #1 people who are the now top earners in US. They overshoot computer engineers. You can check with your friends and your people, whoever is there, or in internet you can check. Because my friends were there, they were working. They told me, they asked me to come, but to construction I cannot go. So please understand the importance of knowing the technology, understanding the design, and it's good scope in it, okay? You should know how to design. Okay. We are here. Board piles installation, major procedures for constructing large diameter board piles. Board means hole, driving a hole inside and then constructing, right? Pile shaft, okay, temporary casing, a shaft driven piles are looking like this. The process is start pre-drilling, okay, pre-drilling, or understand how effectively insert the casing first, and then drill pile shaft and install temporary casing, construct bell out pile cap, clean pile shaft, install permanent liner and reinforcement gauge inside, clean pile shaft again before concreting, okay? This is the standard procedure of installing a board pile. Number 1 started with, above all you should have learned, you should have the borehole test, okay? Borehole test report in your hand. If you want, I will show the pictures from my projects last time. You should have a borehole test results. You should know different layer, at what depth soil, at what depth sand, what depth rock, what depth water. All this knowledge should be there in your mind when you are working at the site. And then pre-drilling, okay? Pre-drilling methods. What are the adjacent side? What are the layers? It is all the knowledge about the surrounding should be there. And then drill the shaft. Install temporary casing. So start drilling the shaft first, and then have a extend pile base. It is important for later on you remove this one so that it will form into the ground. So construct a bell out, small bell out, or a enlarged bottommost, or it is called as pile cap at the bottom, right? And then go on, clean this pile, okay? because after the shaft there may be chances of spilling of soil or some waste materials into the pile. So clean them out before you pour the concrete, or have installed permanent liner and reinforcement gauging so that the concrete will sit in one, in a proper location. Otherwise there is a disruption, there's a pocket, there is a gap inside, right? So all these problem will be created. If it is a reinforced concrete piles, then put the reinforcement inside, then pour the concrete. Do proper compaction, do layer by layer, properly construct layer by layer so that the concrete is settled at the proper time. Okay. Next. Concept of pile load distribution. Okay, so far you saw about the material and how the installation is done. Now you're going to see the type of piles which will take, based on how it will bear the load, how it will resist the load. Okay, there are three main types of piles based on this, based on pile load distribution. We'll see one by one. Let me see the classification that I given here. I think it was given very beginning. Okay, it's better I go from here. I go from here. There are three different types of piles we can classify. Yeah? So far we studied about the material, about the insulation, about the type of hammers, right? The type of, based on the type of hammer also we can classify the work. Now based on the support, or based on how it supports the or resists the load overcoming. Number one, end bearing piles, friction piles, or combined piles. Please remember these points. Can you see the slide? All of you can see the slide?
Yes.
Yes.
Very good. 106. What happened to 8 more people? Yeah, 8 more missing. Okay. You can see the slide, right? I'm sorry, I'm asking quite often. Can see the slide? Okay. Start with end bearing, okay? Second one is friction, third one is combined. These are all based on how it reacts to the load, right? I can also put the type of soil here to match with. Start with, okay, I explain, you tell me the answer. Are you seeing the slide?
Yes, miss.
Yes.
Thank you, sorry for troubling often. Okay, whenever this type of piles, it may be of any material, precast, concrete, wood, timber, or what else? Concrete, wood, steel pipe. Okay, any type of pile. In this type, end bearing means the tip will sit on the rock. Okay, the end will sit on the rock. The end bearing piles are driven until the hard surface or impervious surface, so that the entire load is transferred to the hard surface or transferred to the ground through the end of the pipe. Okay, the arrow will be like this. The load will be, all this entire load will be transferred straight to the end, and then from the end the distribution of the load to the ground surface will be, to the rock will be taking place. Then here you're going to tell me the type of soil and distribution of type of soil. I will just explain how this is reacting. So end bearing piles will resist the load at the bottommost point, where it is sitting on the rock or hard surface or impervious surface. It may be clay belt, it may be a strong clay belt, or it may be rock, and then any impermeable surface. Now second one is side friction. In this case, the bottommost will not react for the loading. Okay, it will not take any load, it will not distribute any load to the ground, but the sides, the soil strata is such a way that the sides, either by natural way, means the soil strata that is available at the ground, natural soil strata available at the ground, will act like a friction material, and due to this friction it will resist the load that is overcoming the pile, not by the end but through the sides. Frictional resistance offered by these sides will take the load, or this frictional resistance will resist the load that is coming over the pile and distribute it. It is not the N. This is how this it is supporting the load overcoming the pile. And this one combine both the end will also distribute the load and also the sides. Okay, the sides friction will be either natural or artificial. They may also have like corrugated, some corrugation, some stonework pipe. Stonework steel pipe will automatically have a corrugation or some perturbation, so that it will offer a resistance to the movement of the soil. It will resist the movement of the soil by due to its frictional resistance, due to its property of friction. So either by natural or artificial. They may have a plastering, also some kind of plastering artificially made, or chemicals used to create a frictional surface on the pile to resist the loading. And here it is both combined. The sides and end will be acting as a proper material for taking the load or distributing the load to the ground. Come on, answer me. What type of soil it might be? What type of soil it might be? What type of soil? Just a guess. Can be wrong. Don't worry. Quick. What type of soil it might be? I say this can resist this material. In what type of soil you can go for this end bearing? In what type of soil you can go for side friction? What type of soil you can go for combine both friction and end bearing? Any answer, please? Just guess. I told you how it reacts, okay? How it take up the load, how it resists the overcoming load, and is distributed to the ground. Just guess. Any guess?
Loam soil.
Sand.
Number one, end bearing. How is it resisting the load? Is it a, okay, I ask this way, is it a soft soil or hot soil? This type of end bearing can be used in a soft soil or hot soil. What? I say the load is only borne by the end, not by the sides. That means what? Appropriate for situation or ground where the soil surface is soft. Okay. Whenever there is a soft soil, you have to reach a hot strata, or you have to reach a very firm soil, right? Then you have to go for end bearing, because these people and this soil cannot take up any load, or this cannot provide any support to the load. So it has to be driven until the hard surface. So these type of end bearing piles are quite common, where the loose soil is very deeper, and then you find a hard surface. Here, this soil
hard.
is yes,
Hard.
this one.
The soil is hard. Not the second one, the side friction one.
Side friction one, here it is a loose soil. It cannot bear any loading. Okay, it is a soft soil, or it is sitting on a soft soil, or a what do you call loose soil, right? The load bearing capacity is very low. Only the sides can bear it, right? Then you have to go for this side friction. All right. And then here, coming here, combined soil. Here, if it is a medium type, right? Medium type means it can take little load, and this portion also can take little load. So go for a combined hard and soft, right? So you can go for a combined type of piles or action piles, so that the medium soil can hold the, or can support the load that is overcoming, or distribute the load properly to the ground. Any question? Three types, repeat. There are three types: end bearing, side friction, and combined. Okay. So this is sitting on a hard soil or a rock, because there is a very deep soft soil inside. You need to go for end bearing. This cannot bear any loading or resist. And then side friction, when the foundation is sitting on a soft soil, you are supposed to provide only until this point, not beneath, right? And you have to you cannot remove the soil, right? You cannot replace or remove the soil. At the same time, the foundation has to be completed. Situation is that you need to complete the foundation. Then go for friction. Means what? Provide a natural or artificial. Sometimes you will have a natural foundation, natural layers of frictional material, or provide an artificial surface so that the sides will take up the load or sides will distribute the load firmly into the ground. That is called side friction. Combined means medium soil. It cannot take heavy load, but at the same time, it can bear it to some extent. So the rest will be distributed by the end and also by the sides. So this is good for medium, soft, and hard soil. Okay. More information about any question, you can stop me. You have time, right? Okay. At 25, I stop for quiz. Is that okay? Do you have any class or midterm today? Any tests?
No.
Okay. I stop at 6:25. Is that okay? Because there are many slides. Okay.
Okay.
And just now we are talking about 3 types, right? N bearing, and then what is this? Maybe medium, and then this hard. Okay. 3 types: N bearing, friction, and combined, right? In pictorial view, we can see here low weight, right? Low weight, but soft soil. Okay. Maybe a clay, firm clay, and then followed by a dense sand, right? Loose soil, suddenly loose sand, right? Or soft soil. Then you should provide a frictional type of pile. Here it reaches a rock surface itself, so you can put a N-bearing piles. At the same time, you look at the load, type of load it is taking, concentrated heavy load here. So it's another picture illustration of how the N-bearing pile is acting. It's just at the end only, at tip only. Load is distributed at this point, and these sides will not take the load. And here, see, it is as though the hands, the resistance offered by many hands on the sides, frictional piles, as though many hands are supporting on the sides due to frictional resistance. Frictional resistance means what? Friction means what? Resistance offered to movement, right? So this will not move. Pile will not move due to the load coming in, due to frictional action or the strength of the friction provided by the material of the pile. Okay, this is just test yourself where you are, how much you learn. Pile materials. How many more slides? 30 more. Okay. Now, I mean, all about the materials and the selection of materials, mean the types of foundation. Pile materials, it may be steel, concrete, wood, or composite. Please listen carefully. Wood means not every wood is possible. Only balsa wood, timber wood, bamboo wood. No, timber only, right? Please bear in mind. And composite. Concrete means in situ or precast. Steel, H pile or I section, H section. The cross section looks like H. That's all. Okay. H pile or just steel pile also okay. These are the types. You can see here steel pile round shape, and precast concrete, right? Well, this is the cover, and this is the cover provided. This is the reinforcement. I take the laser point. You can see the concrete pile. Concrete means using the grade, right? Concrete grade, maybe M5, M15, M20. Depends on the strength required. So you know the grades, right? Concrete grades. Later I will take a separate class on that. But for now, if I say M15, it is 1:2:4. 1 portion of cement, 2 portion of sand, and 4 portion of gravel. Mix with, make the concrete, pour it, right? And this is the casing, right? And this is the reinforcement. And between is a cover, maybe 20 mm, 2 centimeter, 3 centimeter, depends lah. And then the concrete is poured. Wood pile is like this, circular, right? One piece, and strength has to be checked before using. Types of piles again. Concrete piles can be used for driven and bored, both types of action. Steel piles, only driven piles. Timber piles, you cannot melt into steel and pour it. Timber piles, driven piles only. because precast. Composite piles. Okay, start with concrete piles. Concrete piles again further classified into cast in place, precast, and drilled shaft. Drilled shaft you can pour concrete. And then steel piles may be of H type, cylindrical type, tapered type, right? Tapered type, where you need to form into the soil. We'll see in pictures later. Cast in place concrete piles formed by driving a cylindrical steel shell into the ground to the desired depth, and cavity of shell is filled with fluid concrete. So repeating the same. Provide the scaffolding and pour the concrete inside, maybe cylindrical, square, rectangular, or of any type required. It's mostly of circular type. Steel shell doesn't contribute to the load transfer capacity of the pile. Okay. The steel shell does not contribute to the load transfer capacity. Yeah, the casing cannot take any load. That's what the information here. Its purpose is to open a hole in the ground and keep it open to facilitate the concrete, right? Same function as a formwork. Okay, see here the different types of concreting. The insulation is given here, end bearing, and then the pile is driven. The pile is taken by the cranes and driven into the ground, and then pouring. Different types you can see one by one pictorially. Advantage, you can, if you want, I will explain to you later. Let me go through some theory first. These are the different types, maybe pouring or drilled. I mean, bored or pouring. Sorry, driven or this is like driven, driven or poured. This is driven type. This is pouring type. Advantages and disadvantages of cast in situ piles. We already studied, right? This one, cast in situ. Okay, quickly. Less wastage of material, right? At the same time, you cannot customize it. A disadvantage, right? Time spent on curing is saved, right? You don't have to allocate time in your program schedule or project schedule. Can bear heavier loads by improving their X-sectional profile. Example, pedestal pile. Okay, you can choose the type of pile which can have more. If it is poured concrete, is always circular or maintain a say solid shape, right? But here you can have different shape by testing before it is brought to the construction site. You can test it and economically design the piles. If it is can bear heavier loads by improving their X-sectional profile. Example, pedestal pile. Advantage of cast in situ, right? This is cast in situ. At site you can, oh I confused it, sorry. Time spent on curing is saved. Advantages. What is this? Sorry, I will check the slide and then I will redo this one. I'm a bit confused in this. Come to precast concrete. It's all about precast only. Precast concrete piles. Okay. These are the RCC piles which are square, circular, or octagonal cross section. Okay. Octagonal. What's the number of size? Octagonal. What's the number of size? Octagonal. Quickly. Excuse me. Hello. Hi.
Yes, miss.
How many sides? Octagonal.
8.
Okay. So you can maintain any number of sides. Number of sides depending on the mold and depending on the situation you have. Include high strength and resistance to decay. Right. It's a heaviest, brittle, and lack of tensile strength. Just now one student asked what happened if it is brittle, right? So you go for precast. It is the heaviest. Go for the precast, which is heaviest, good in strength, right? Good tensile strength, all type of strength is achieved. The construction requires care in handling and driving to prevent pile damage. Very important is during construction, right? During handling, care should be taken so that it is not damaged. Usual length is 10 meter to 45 meter. Load is up to, see the heaviest load, maybe skyscrapers, 75 loads, Burj Khalifa or our TRX or the new one, Bandaraya Tower. All these things will have these types of piling. Okay, what's the time now? We have few more minutes. Different tags and based on the tag it may be varying. Still, I will continue the next class. I stop here with the steel piles. We just finished which type? Gas in situ. Concrete piles. We just finished the concrete piles. We will start with the steel piles next class with the advantages and disadvantages. I will correct the slide and bring it. Any questions so far? Any question?
No.
Okay, I stop here. Are you ready for quizzing?
Yes.
Okay.
Well, today's episode is not about sex. It's about foreskin versus no foreskin. Okay? So I know this is a tough topic because we always body shame females, but we also body shame males too. Like foreskin or no foreskin.
Hello. What's going on? Are you seeing movie? Just another few minutes, please. My quizzes. Today I will continue with the D foundation. That is, I've set another set of questions for D foundation. You can play that. Do you need the website? All of you having, right? All are having the website, right?
Yeah, let's go.
Okay. Sorry. One moment, sir. How do I? Where is it?
Let's go, one point.
Yeah.
Screen is gone.
Please hold on. I will try this one. Okay. Now I will share this slide. So take this website, joinmyquiz.com. All are having, right? No issue, right? All are having this website, right?
Yes, miss.
Okay, thank you. And one good news today I wanted to share with you. Okay. We got big size screeners in our lab, concrete lab. Today we bought and it is being supplied. I just want to share with you this news. You can see bulk amount of materials. Okay. Just for your information, UCSI have bought big screeners.
Can you post the link? The quiz link.
Okay, I did it. One moment. Hello, what is this video? Bad videos. Don't play here. Technical play. Not jolly play. Just jolly play. And the number also I posted. I wanted to go for Kahoot, but you will suffer with the two devices. That's why I used the quizzes. Continue with quizzes, which gives you power up and then bonus points. If you do more than 5, there are some bonus points and gifts, so you can enjoy. That's why I continue with the quiz. You can suggest to me, let us live with the quiz or change to Kahoot. All right, time up. Can I start?
Yes, start.
106 only today. What happened? 8 more missing. Maybe pending famous debtors. Wait for 4 more because we are 106. At least 1 more minute. We can spend just 3 or 4 minutes only for playing. Don't worry. Read the question carefully. There are indirect answers. Okay, I start.
Best we can leave if we finish.
Yeah, please leave. You can leave. Finish.
Teacher, are there any marks for quizzes?
Yes, participation take has mark. Not for the answers you. Give me the attendance. Done already. Completed the quiz. Timing also important. Can cover up. Those who are completed can leave. Show the winners by next class. I will wrap it. I'm pausing my slide right. Yeah, I mean, good going, good. Get up. Warm cup. Alif.
Yeah, then you can leave the class.
Yeah, you can. If you want, you can leave. 92 have completed. Once all 112 have done, I will leave. I'll post the winners next class. Already Nancy, how? Can you please check the screen? 97 done, 93 done. Get more people. Seven more people left. Seven more people. Tansi Hao, Didi, Uwe Jun, Khalid Mohammed Ali, good going. Mayak Mao Bin, Mao Khan, very good. Muhammad Munib, Wang Kape. People, then I end the game. Getting scoreboard. Don't leave for the before completing. Finish the quiz and leave. Join the class. Don't take much time, you will not get 30 points. 30 seconds, please, 30 seconds. More quickly. Malik Muhammad Ali, Wei Jun, very good performance. They're getting some, 100%. Mustard. They're getting some stickers, some wallpaper, I think. But there are wallpapers. Yeah. Let me see. Okay, thank you so much. Bye-bye. I exit. Bye-bye, see you. See you next class. Any question you can ask me in between the class or before, right? We are hardly spending 1.5 hours here. You can ask me anytime. Just text me or call me for any question. Bye.